Hi guys. Today we are starting unit 16. This is our second to last unit. It's on oxidation reduction. I don't love this unit, but it's relatively short, and hopefully we'll just kind of go through it and then I'll be done. Okay, so we're going to spend this week on it, and basically part of next week too. And then that's it. Okay, so let's get started. And then we have one more after that. Okay, so this top part should be review for you. So why don't you take a minute and see how much you remember. Also for this unit, you're gonna need your periodic table out. So make sure you have that available for this recording. Okay, so as a reminder, group 1 are called the alkali earth. I don't know why I said that. They're the alkali metals. They have 1 valence electron, their charge is +1. Group 2 are your alkaline earth. Two valence electrons, those are electrons in your outer shell, +2 charge. So remember when we're talking about charges, positive means lose and negative means gain. Okay, 13, 14, 15, 16, we don't need to worry about names of. So we'll just do valence electrons and they just go in a pattern. 4, 5, 6. Okay, so the charge will be +3. So if you have 1, 2, 3 valence electrons, you would lose them in order to get a full octet. If you have 4, that's where things change. You can lose or gain. So it's positive or negative 4. Okay, 5 valence electrons is where things start changing. It's -3, meaning you would gain 3. 6, -2. 17 are the halogens. 7 valence electrons, -1. 18 are the noble gases. They have 8 valence electrons with the exception of He, which is 2. And they have a full octet, so their charge is 0. Okay, so now let's get started with new stuff. Okay, so we're going to talk about oxidation numbers today. And oxidation numbers are a fancy way of saying the charge. So there's a bunch of rules. We're going to go through rules for elements and monoatomic ions and also compounds today. And then I think tomorrow we'll do the polyatomic ions. Okay, so rules for assigning oxidation numbers in elements or monoatomic ions. A free element, that means just when an element is written by itself, not connected to anything else, the charge is always 0. So like if we have a piece of sodium, it would be a 0 charge. Likewise, if you're holding like a piece of aluminum foil, its charge is 0. A monoatomic ion is an atom that has a charge. So whenever you have an ion, that charge is equal to the oxidation state. So the oxidation number of a monoatomic ion is equal to its charge. And it's whatever charge is written in the upper right-hand corner. So you don't even have to look anything up quite yet. All right, so Na has a positive charge. Instead of just writing positive, I would write +1. Okay, so you should be able to do this in like 2 seconds. So practice 1, determine oxidation number of the following either atoms or monoatomic ions. So basically your answer is going to be either 0 or it's going to be whatever the charge is that's written. So since this is a free element, oxidation number is 0. Same with O2. It's an element still because it's combined with itself. So its charge is 0, F2, free element 0, lithium, free element 0. Calcium, we have a monoatomic ion because the charge is written, so it's +2. Chlorine, a monoatomic ion because it has a charge. It's negative, which means -1. And then back to helium, where we have a free element is 0. Okay, so let's do some compounds. Okay, so group 1 ions, so if you imagine the periodic table, something like that. Group 1 are any ions that are found in the first column. They're always +1. Group 2, they're found in the second column. They are always +2. Aluminum is over here, it's group 13. If you look at the ions or the atoms that are in group 13, some of them are always +3 and some of them can be +3 or other charges. Aluminum is one that is always +3. Fluorine is in group 17, it's always -1. But if you look under fluorine, like chlorine, bromine, and iodine, they can have multiple charges. So like bromine can be -1 or +7, or they might have a +5 charge in there. So they can change, but fluorine is always -1. So this will be important when we start doing our compounds. Oxidation number or charge of hydrogen is usually +1. There are some exceptions, and oxidation number of oxygen is usually -2. And then this one is important. The sum of all the charges have to equal 0. And the last thing is the positively charged ion comes first, with the negative coming second or last. There are a couple of exceptions to those rules. So let's talk about some exceptions you'll see below. So a metal hydride is anytime you have hydrogen combined with a metal. So basically when hydrogen is second. So lithium is group 1. And according to these rules up here, group 1 is always, and these should say like group 1 metals, so not hydrogen. Group 1 is always +1, so that means the positive is the Li, so H has to be -1. So that's one of the exceptions where H is not +1. Peroxides are also weird. Instead of O being -2, it's -1. And then these two examples are where the positive ion is actually second. So usually the positive ion is written first, but in this one, nitrogen is -3 and hydrogen is +1. So you can see that the positive comes second. All right, so moving on to the next page, we're just going to do a little bit on this page. Hold on, my husband's phone is on. Okay. So this page has some examples, and today I think we'll probably only do the top half of this page. So on yours, the individual charge has a big box. That's just to highlight it. Okay, so this is what you do when you have a compound. You have to look up the things you know first. So if you take a peek at your periodic table, oxygen always has a -2 charge. So you're going to start with oxygen. And I'm writing this in the individual charges because that is the charge of 1 oxygen. now I'm going to multiply how many oxygens I have times its charge. So -2 times 4 is -8. So going down, we multiply. We've kind of done something like this before, but you probably don't remember. Okay, now between these two, we have hydrogen and phosphorus. So if I think back at my list, like of rules that I have, we didn't have a rule for phosphorus. So I'm going to go with what hydrogen usually is. So hydrogen is +1. There's 3 of them, so I'm going to multiply. So +1 times 3 gives me a +3. Okay, so now I need to figure out what is missing. So the total charge of all the charges in a compound have to equal out to 0. So if you think about that, it should be easy to find out the charge of phosphorus. So we have a +3 and a -8, and then what is missing to make 0 would be a +5. So the way I do it in my head is I think about what would give me my +8 here and to balance out with my -8. Okay, so now I look at phosphorus. I only have one of them. So it's kind of like I'm doing 5 divided by 1. So on top here, my charge would be +5. So when I report my answers are the individual charges, not the total charges. This part down here is just to keep track. I recommend doing it, but these are not the answers. Okay, so let's do the next one. Okay, so I have silver and I have sulfur. So if I'm looking at the list of rules I just gave you on the previous page, I don't have rules for either of them. So I'm gonna go take a peek at my periodic table and look to see what's going on. So I don't have mine in front of me, but I'm pretty sure that sulfur is -2 or +6. So I'm gonna look to see what silver is, and I find that silver is always +1. Okay, so I'm going to do silver first because it only has one option. So +1 times 2 is +2. I need to make sure my charges equal out to 0. So I have +2 and a question mark equals 0. So when I add those numbers together, this has to be -2. If I look back, I only have one sulfur, so I can just leave the individual charge as a -2. And then my answers would be +1 and -2. Okay, so just a couple tips. In the next set of practice, I did not give you any with 3, but when you do the ones with 3 atoms, you do the first and last, and you always save the middle one. And then on the individual charges, you just kind of have to check, what do you know? So I would go look in my periodic table and look to see, of those 2 elements, which ones have only one option for charges. Okay, so why don't you guys push pause and try to do these problems, and when you come back, I'll go over them. Okay, so when I look in my periodic table for chlorine and potassium, I noticed that potassium is the one that only has one charge. So that's the one I'm going to start with. So potassium is +1. I multiply by how many I have. So +1 times 1 is +1. I know that my total charges have to equal out to 0. So in order to get me to 0, chlorine has to be -1. I only have one chlorine, so I know that it's just -1. So these are my answers here. Okay, on the next one. Lead and oxygen. What are you doing? What are you doing? Oh, you're punching. Okay. So on the next one, I noticed that lead has multiple charges, and I can remember from my list of rules that oxygen is always -2. -2 times 2 is -4. The total charge has to equal out to 0. So if the total charge has to equal out to 0, that means lead has to be a +4. And since there's only one of them, lead is +4. And those are my answers, +4 -2. The name of that would be lead 4 oxide. And this is where we have done these charges before. Okay, next one, we have magnesium and bromine. So if I look at bromine, bromine can have multiple charges. But if I look at magnesium, magnesium is always +2. So I'm going to multiply. +2 times 1 is +2. So these are all the individual charges up top, and these are all the total charges on the bottom. I know that my total has to equal out to 0. So if I'm solving for bromine, that has to be -2. We haven't had one like this yet. So bromine is -2, but there's 2 of them. So I'm going to divide when I'm going back up by the number I have. So multiply going down, divide going back up. So -2 divided by 2 is -1. And those are my answers. Okay, on the next one, I can do either of them. When I have oxygen, I generally like to start with oxygen, but it doesn't matter. So I have -2 times 1 is -2. That means hydrogen has to be +2, but I have 2 of them. So I divide by 2, so +1. So my answers would be +1 -2. And then in the last one, zinc and sulfur. Zinc always is +2. I only have 1 zinc, so it's times 1 is +2. To equal out to 0, sulfur would be -2, and I only have 1 of those, so -2. +2, -2 are my answers. Probably. Okay, so we're gonna stop there, and we'll pick up tomorrow with rules for assigning oxidation numbers in polyatomic ions. All right. Talk to you later.